All right, welcome back to problem 4 of exam 3. I do apologize if you can hear the rain, and there's unfortunately not much I can do about that. So anyways, getting into the problem, we are given a closed piping system here that has water flowing through it, and we are asked to find the pressure on the second floor. And thankfully it gives us the velocity of the water on the first floor, the velocity of the water on the second floor, the pressure of water on the first floor, and even the height. So this is going to be a very easy problem for us to solve. We'll start out by writing the Bernoulli equation here. So that basically says that the pressure on one end, so we'll do pressure on the first floor plus 1/2 times the density of water, rho here, times velocity of the water on the first floor, excuse me, plus rho times gravity times the height of the first floor here, which is going to be equal to 0. So we're actually going to not worry about that, but we'll keep writing it out in case your problem differs. And all of this is equal to, directly proportional to, the pressure on the second floor plus 1/2 times the density of water here times velocity squared, velocity of the second floor squared plus the density of water times gravity times height of the second floor. So this is a very important equation for you to know. If you're lucky, your professor will give you an equation sheet with this on the exam. If they don't, make sure to have this memorized. This is very important. And if your application differs, the density of whatever fluid you're working with is going to be the rho here. And then if, let's say, you have varying heights, then you'll have the height of whatever the pressure is on the one end, and then height on the other end. But in our case, we'll say that the first floor, the height is 0. So this is going to be crossed out. We're not going to worry about this. Okay, so let's go ahead and next analyze our values here. So it gives us the pressure on the first floor there. So P1 is equal to 4 times 10 to the power of 5. And then it gives us the speed of the first floor, the speed of the water on the first floor, which is going to be velocity 1 is equal to 1.8. And then it also gives us the height of the first floor here, or the second floor. So we have height 2 is equal to 3.5. And then we have here, let's see, we also have the velocity on the second floor. So that's V2 is equal to 4.6 there. Okay, and then I believe that is all the values. Yeah, oh, and then the density of water. Okay, so hopefully your professor gives this to you as well. If they don't, we'll note that the density of water is 1,000 there. Pretty simple. Very easy number to memorize. So, okay. The one thing we aren't given is the one thing we need to find, and that is pressure 2 here, pressure on the second floor, but we have values for everything else. So all we have to do is isolate for pressure 2. So we'll go ahead and do that. We are going to quite simply just subtract these two equations over to this side, and that will instantly isolate us for pressure on the second floor. So we'll do pressure on the first floor plus 1/2 times the density of water here, velocity of the first floor squared, plus and actually we're not going to worry about this guy here because it tells us exactly that the second floor is 3.5 meters higher. So that's why we're saying that that is 0. So this cancels out. We'll subtract these over. So minus 1/2 density of water, velocity of the second floor squared, plus rho times gravity times height difference of the second floor. And that is equal to pressure 2. Okay, and from there, we are going to just plug and chug the values that we have. We have all these values. There's only one variable that we don't know, and that's what we're solving for. So let's go ahead and do pressure of the first floor, which is 4 times 10 to the power of 5. All right, and that's going to be plus 1/2 times the density of water, which is 1,000. And we'll actually put these in brackets to help you follow along a little bit better here. Okay, and that's going to be the velocity of the water on the first floor squared, which will be 1.8 squared. Okay, and that will be minus there 1/2 times the density of water again, 1,000, times the velocity of the water on the second floor, which was 4.6. That's squared. And that will be minus the density of water here times gravity, 9.8, times the height of the second floor, 3.5. 3.5. Okay, and that gives us our value in pascals for pressure 2. So pressure on the second floor is equal to 356,740 pascals, because we're using pascals on the pressure for the first floor. But the problem asked for pressure in atmospheres. Thankfully, though, they gave us this little conversion chart right here. So all we need to do is convert this, and we'll do that like this. 1.01 times 10 to the 5th pascals, 1 atmospheres. Now, technically, we're dividing by this value here to convert it to atmospheres, but if you kind of struggle with grasping the concept of conversion, sometimes like this helped me a lot. You're basically multiplying it by this conversion ratio, and you're trying to cancel out the pascals and replace it with atmospheres. So if you multiply it by this conversion ratio here, the pascals are going to cancel out and you're left with the atmospheres. So let's go ahead and do that. So 356,740 divided by 1.01 times 10 to the 5th power. And that gives us our value here. So that pressure 2 is equal to 3.532079,208 times 10 to the 10th power in atmospheres. And so that is our answer for problem 4. Very simple, as you can see. We quite literally are just using this equation and plugging in the values. So hope you found that helpful, and I'll see you in the next video.